Hello and welcome to this lecture on integral calculus. In this video, we are going to solve some problems under the title Areas Double Integral with Cartesian Coordinates. So the first problem, we want to find the area of circle using a double integration. Sometimes they will not give the exact equation, so we want to know the equation of the circle. So simply, let's begin. The area of circle. Finding area of circle is equal to the 4 times of area in the first quadrant of a circle. So here, let's see. Assume this is a circle. So here they have mentioned that x square plus y square equal to a square. So it will be of x minus h whole square plus y minus k whole square equal to a square. So the radius of circle will be equal to a. So it varies from 0 to a. So 0 to a. So instead of finding the area of whole circle, it is enough to find the area only in the first quadrant. If I multiply with 4, then it is enough to find the total area. So I may take the first quadrant alone. Of course, this curve will be x square plus y square equal to a square. So I am taking the first quadrant alone. So this is a circle equation x square plus y square equal to a square. So here the center is 0 comma 0. So I am getting x square plus y square equal to a square. If they have given any of center specifically, then it will be of x minus h whole square plus y minus k whole square equal to a square. Now simply it is a circle with the center 0 comma 0. So this is the equation. Clearly they have given in the problem. If they have mentioned any of specific center, then you have to go with the general formula. So this is the first quadrant. Now we want to evaluate the area of a circle. So they have given the area of circle. We have, it is enough to find 4 times the area in the first quadrant. So area we can calculate using a double integral over the region R. So I may choose dx or dy. So to find the area, enough to find dy dx. Sometimes you may choose dx and dy also. It is also okay with that. So now we need the limits of y and dx. How do you find the limits? So if I choose dy dx, it represents a vertical strip. So I have to draw a vertical strip which is parallel to y axis. Okay, so then by using a vertical strip, how do we find the limits? If it is parallel to x axis, we want to find the x axis limit first. It works on the horizontal strip. Now they have given a vertical strip. I have chosen dy dx, so it represents vertical strip, so it will be parallel to y axis. First we want to find the limit for y. So the lower end of the strip is joined to the line x axis. What is the equation of x axis? Y equal to 0. So it is a lower limit. Then you have to find the upper limit of y. So the upper end of the strip is joined to the circle. The equation of the circle is x square plus y square equal to a square. I need the value in the term of y. So it can be written as y equal to square root of a square minus x square. So the upper limit of y will be square root of a square minus x square. Now the next we need the limits of x. So this is the region. So here x value is varying from 0 to a. So the lower limit will be 0, the upper limit will be a. So these are the new limits. You understand? So with this I'm getting that area equal to 4 times of 0 to a and 0 to square root of a square minus x square. Sometimes you may choose 4 into, if I choose dx dy, Then according to that, you will get the horizontal strip. Horizontal strip, na? How it is will be, I may choose horizontal strip. It is parallel to x-axis. So for dx dy case, we have to start from the left hand to right hand. Left hand is, here it is parallel to x-axis, so I will write the x limits first. So here this will be the y-axis. The equation of y-axis will be x equal to 0. The right end of the strip will be joined to the circle. So I'm getting that x equal to square root of a square minus y square. Then this is the region. The y varies from 0 to a. So y will take the limit y 0 to a. So if you choose dx dy, then the limit of x will be 0 to square root of a square minus y square. Then y limit will be 0 to a. So either you can choose this or that. Okay, with the corresponding limits. Then I'm going to evaluate this with the inner integral dx into integration. It will be y. If I substitute the upper limit dy, I will get y alone with the limits of 0 to square root of a square minus x square. So I am substituting the limit, 0 will be 0 simply. So I'm getting the resultant. This will be the outer integral. So I want to evaluate this. To evaluate this, we need some standard formula. The integral of square root of a square minus x square can be written like this: x by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a and plus c. So this is the formula. What we want to evaluate, 4 into 4 times of this integral value with the limits of x. So I'm playing the limits and multiplying with 4. I'm getting this result. Then I will apply the upper limit. So just see here what you will do. If I apply the upper limit a, if I apply the upper limit a, so this term becomes 0, a square minus x square, because I will apply the value a to x. So a square minus a square, you will get 0. So the whole term becomes 0. So plus here, what will happen if I substitute a square here? A here instead of x, sine inverse of x, already there is a square by 2. Then sine inverse of x, a by a, na, it will be 1. So this will be the value from the upper limit to the lower limit. If I substitute the x as 0, that this term becomes 0 plus here a square by 2 sine inverse of 0 by a. So it will be of sine inverse of 0. Sine inverse of 0 means becomes 0. So finally I am getting the value a square by 2. Sine inverse of 1 will be 90 degree. So it will be of pi by 2. So therefore we get the step, and finally I am getting the answer pi a square. So the area of the circle, it will be of pi a square. The next problem, they have given a double integral. We have to evaluate this within the given region. What are the region here? X equal to 0, y equal to 0, x plus y equal to 1. So here, how we may draw a region? First thing, I may draw a x-axis. Y-axis. So x equal to 0. X equal to 0 represents the y-axis. X equal to 0 represents the y-axis. I'm just drawing roughly. And y equal to 0, it represents the x-axis. X equal to 0 represents y-axis. Y equal to 0 represents the x-axis. Now x plus y equal to 1, a simple linear equation in two variable. If I use to put x equal to 0, I will get the value of y equal to 1. So there will be a point 1 comma 0. Again, if I choose y equal to 0, I will get 1 comma 0, 0 comma 1 and 1 comma 0. So here it will be of 1 comma 0 comma 1, and I may choose here as 1 comma 0. I will draw a line like this. So this will be x plus y equal to 1. So this will be the region. So within this region we want to evaluate this given function. So of course what I'm getting here, 0 comma 1, here it is 1 comma 0, and here 0 comma 0. It makes a triangle, so I'm choosing these 3 points for a right triangle. So this is the graph, and here clearly they have mentioned we want to evaluate this double integral in the form of dy dx. dy dx. So dy dx represents a vertical strip. Okay, so we want to draw a vertical strip. Okay, so now we want to find the limits because they have not given any of limits, simply a region. Within this region, we have to find the limits. How do you find the limits? For dy dx, a vertical strip, it is parallel to y axis. First, we want to write the limits of y. So the lower end is joined to the x axis. The equation will be y equal to 0. Then the upper end of the strip is joined to the line x plus y equal to 1. So here y can be written as 1 minus x. So the upper limit of y will be 1 minus x, and this is the region, and here we want to decide for the value of x. So x varies from 0 to 1, so the limit of x will be 0 to 1. These are the limits. So here clearly x takes 0 to 1, y takes 0 to 1 minus x. Okay, so now remaining as similar, what we will do, we will evaluate this integral. So I'm just taking the inner integral 0 to 1 minus x square plus y square dy and dx. First I will evaluate the inner integral. So I'm taking out the inner integral and I'm splitting this x square and y square separately for the integral values, and here x square will be a constant and integration of dy will be y, and I will substitute the limits. Here it will be of 0 and 1 minus x, so it becomes x square into 1 minus x, and y square, integral of y square dy will be y cube by 3. So then if I substitute the limits as 1 minus x, then I will get 1 minus x whole cube by 3, then 0 becomes 0 simply. So this will be the inner integral. And next we want to evaluate the outer integral. With this I want to integrate with respect to x. So still you can split this integral 0 to 1 x square into 1 minus x. We can multiply this x square minus x cube dx, and 0 to 1 1 minus x whole cube by 3 dx. So I'm taking the first part alone. I'm taking the first part, and the next break into two parts. I'm taking the first part and it is multiplied here, and x square, it will be of x cube by 3 while integrating with respect to x, and here x cube while integrating x, it will be x power 4 by 4, and if I apply the limits I'm getting the value 1 by 4, 1 by 12. 1 by 3 minus 1 by 4 equal to 1 by 12. On the next I'm taking the second part. I'm taking the second part of this integral. So here it will be of 1 by 3 is simply a constant. I'm taking 1 minus x whole cube. So we know that a minus b whole cube. By using that formula I have expanded like this, and now it is easier. We can split the integral. So here how we can make a substitution, simply 1 by 3 will be a constant, and integral dx 0 to 1 minus 3 will be a constant, 0 to 1 x dx plus 3 into integral 0 to 1 x square dx minus integral 0 to 1 x cube dx. So I will get the value of x 0 to 1 minus 3x square by 2 0 to 1 then 3 x cube by 3 0 to 1 minus x power 4 by 4 0 to 1. Then if I apply the limits, I will get the value 1 minus 1 by 3 by 2, 3 by 2 plus 3 by 3. I'm getting that value 1 and minus 1 by 4. So here I'm getting it. So finally, if I simplify this, I'm getting the value 1 by 12. So the first part I'm getting 1 by 12, and the second part also it will get times 1 by 12. So while adding both, because if you see the previous step, we have break into 2 with the plus, so we have to add up both. Finally, if I add both, I'm getting 2 by 12, it will be 1 by 6. So finally, that double integral value, it takes the area as 1 by 6. Next, take this problem as an exercise. As the previously we find the area of a circle. Now we want to find the area in the ellipse. So here I have given the equation x square plus a square plus x square by a square plus y square by b square equal to 1. By using the double integral, at last you will get the answer as pi ab.